In this video, we are taking a look at how to create a particle disintegration effect inside Blender. It works for both static meshes like this owl statue and animated ones too. And the best part, we are doing it all using Particle FX. Particle FX lets you create stunning, unique particle effects quickly and easily, all powered by geometry nodes right inside Blender. Before we start, a quick shout out to my rendering partner, Fox Renderfarm. Fox Renderfarm is a leading online render farm service that I have been personally using for years. It's fast, secure, and super reliable. A lot of the amazing projects you have seen over the years were rendered using Fox Renderfarm. You can sign up using the link in the description and get a $30 render coupon to start rendering your next project. Alright, here I have this owl statue mesh loaded up, and I am currently using Blender 5.0 beta. Before we start with Particle FX, make sure that in Preferences, File Paths, Access Libraries, the import method is set to append. By default in 5.0, it usually set to packed, but we need append so we can edit the geometry setup and materials later. You can add particle effects directly to the owl mesh or to a separate mesh that references it. Here I'll just add it directly to the owl mesh. In the Modifiers tab, click Add Modifier Particle Effects Emitter and choose this emitter type. Set the emitter type to Mesh and check the Self box to reference the owl mesh. Now I'll decrease the point radius and increase the point density. There are a few distribution options here, and you can even extract UV maps. If you open the mesh data properties of the owl mesh, copy the UV map name under UV maps and paste it into this field to extract the UV data into the particles. Since this is just an emitter, you won't see anything when you play the animation yet. We can come back and tweak the particles amount later, so let's move on. Next, let's add a mask. Go to Add Modifier, Particle Effects, Mask and select Mask Sphere. Our mask controller seems to be tilted a bit. That's because our owl mesh has some rotation to it. So I hit Ctrl A and apply the rotation. This mask modifier helps you mask in or out a certain area of the emitter that you are going to feed in to a simulation later. Make sure the object and modifiers are selected and gizmos are enabled. Now you can use this dial gizmo and this translation gizmo to control the location and the radius of this mask. You can control them from here as well. To visualize the mask area, enable the delete option. I'll increase the particle count, and you can see here at the sphere edge it's not uniform due to these noise settings. If I set this to 0, you can see the masking area looking very spherical. You can use these noise settings to break that uniform look. For mask type, you have inside, outside and edge options. Edge masks a thin region around the edge, which you can control using this epsilon value. Now there's this simulator checkbox. That's what we'll use later. It calculates the mask over time and create an attribute. But for now, we'll just preview it with delete enable. I want the disintegration to start from the bottom left and move toward the top right. So I'll position the mask here, scale it down until node particles are visible and keyframe the radius and position. Then turn on auto keying. Move a few frames forward and scale it up while moving to the top right. On the timeline, select those keyframes, press T and set them to linear. I'll set the animation length to 120 frames. Don't worry if the mask doesn't cover the entire mesh at the end. When we enable the simulated option, it accumulates over time, keeping previously masked areas intact. Now enable simulated. You won't see anything updated visually, but you'll notice Blender caching the simulation in the timeline. Next, I'll add the simulator. Since we are using a mask, I can use this mask particle simulator. When we hit play, you can see the mask particles getting simulated. It is stopping around frame 50, so I'll set the end frame to match the animation length. Looks like I missed a bit at the bottom, so I'll disable the simulator and reanimate the mask slightly. Much better. Now let's polish the simulation. I want the particles to move slightly upward and to the left. So I'll tweak those velocity values and add a bit of randomness. The disintegration also feels too fast, so I'll readjust the mask keyframes. In the lifetime section, I'll add some randomness to the particle's lifespan. Next, I'll enable noise to add curl motion to the particles. Some particles aren't affected, so I'll lower the threshold to make sure all of them receive the noise. Then adjust the strength and other noise parameters until it feels right. I'll also enable drag to add some resistance. That's looking good. Let's move on to rendering. I'll add a point cloud renderer. Right now we only see the mass particles. That's because of the default scaling type. Set it to one of the deceleration options. That keeps the particles at their original size until they are simulated, and then they gradually scale down. I'll stick with the linear type. Since we are using a point cloud renderer, let's switch to cycles for rendering. To edit the materials, I'll split the window and open the shader editor. Here's the owl's original material. I'll add a new slot and add the point renderer material there. Remember how we extracted UVs earlier? Duplicate one of the attribute nodes and rename it to UVs. You'll see the UVs correctly mapped on the points. If you're wondering how you can remember these attribute names, you can check here in the modifiers what attributes each modifier writes. I'll delete the existing emission node. We'll build the shader from scratch. Now, from the owl's original material, copy the texture node, paste it here and plug the UVs into it. Now you can see the texture nicely mapped to the particles. Add a principal BSDF node. Since there are no lights in the scene, I'll disable scene world and select one of the HDRIs to view the material in cycles. I'll reduce the roughness and give some clear code to it. Now I want the disintegrating particles to have a different color. I don't have a mask attribute here, but I can use this NH or normalize edge attribute. This color attribute links to this color and emission gives me this emission strength from here. We can use all these to make the effect. So I view the NH, plug it to a mix node factor and change the mix type to color. Connect the texture to color A and set the color B to a light blue. Plug the output to the base color. Now, as the particles disintegrate, they gradually shift to blue. You can plug a float curve node here to control that gradient. Plug the color attribute into the B input to control the tint using the modifier's color settings. That's it for the material. Now I'll reduce the particle size a bit, increase the count, and we have got a beautiful disintegration effect. Once everything is finalized, I can head over to Physics tab and bake the simulation. That was a still mesh, but What if you want to disintegrate an animated mesh, like this one here? You can use a normal emitter, but due to mesh deformations, particles may jump or slide across the surface. That's where animated mesh emitter comes in handy. It keeps the particle distribution consistent throughout the animation. Let's try it. This time, instead of doing the simulation on the mesh itself, I add a separate mesh plane. Call it simulation. In the modifiers tab, go to add modifier, Particle FX, emitter, and this time choose animated mesh emitter. This emitter has two modes, proxy and bake. Both achieve the same thing but with different workflows. Let's start with proxy mode. Select your animated mesh and duplicate it. On the first frame, apply the armature modifier. That makes a still copy of the animated mesh. I'll name it proxy. Now in the animated emitter, select your animated mesh and proxy mesh. Lower the scale, increase the density and play. You'll see the particles sticking perfectly to the surface without any jitter. I'll hide these and set the viewport shading to random. And you can change the particle density and it will update immediately. Now let's switch to bake mode. Here I select the animated mesh and we don't need the proxy mesh because we are going to make the proxy mesh inside the geometry node setup. So if I open up the geometry node editor and select this modifier, you can see there's this node you can't miss, this bake node, surrounded by a bright green frame. All you have to do is click bake while on the first frame. This will make a proxy mesh inside the node setup. And when you play it, particle will stick to the surface just like before. But changing the density won't update immediately. You have to delete the bake and rebake it again to apply those changes. It's a bit more back and forth, but this method gives you faster playback. You will notice it in big scenes when you are dealing with millions of particles. So my go-to method is to use proxy at the beginning to get the basic shape of the simulation. Then I switch to bake method and bake the emitter with a higher particle count. One advantage of using a separate simulation mesh is that you can add multiple emitters. So I duplicate this emitter, change the distribution to volume and add particles inside the mesh. These also will stick to their places just like before. Let's add a mask sphere. Set it to delete and type to outside just for now. Then, just like before, I start animating the mask. After that, switch it back to inside and enable simulated. Particles are not animating anymore. When you're using an animated mesh, make sure to check this box as well. Now, add a mask simulator. Set the end frame and check this animated emitter option. I adjust the keyframes of the mask to smooth the disintegration. Then, just like before, I play with the velocity, lifetime, noise, and drag options to get the simulation look for this disintegration. I also want the particles to collide with the ground plane I have here. I select that plane and move it to a new collection. Then in the simulator, enable collision and select that collection. Reduce the bounce and friction. I just want them to settle on the floor. Now you can see some particles hitting the ground and stay in there. After all that, I add point cloud renderer. Set the scale size to deceleration type. Then I go back to our first emitter, Reduce the particle size, increase the density, and add some randomness. Do the same in the other emitter as well. We have the simulation. Just like before, we can tweak this default material. Switch to Cycles, open the shader editor and select the material from here. Add a principal BSDF. Then plug a float curve to NH attribute and multiply that by the emission attribute. Use that as the emission strength. Set the color to red and adjust the float curve. Plug the float curve into a color mix node and make a color difference as well. Delete this emission shader and plug the color attribute into emission color. Now we can adjust it from here, along with the emission strength. In fact, I can set this to random and have two colors. I set the random parameter to normalize edge and change the color over time. Let me change the view transform settings a bit so you can see it clearly. Finally, switch to bake mode. Bake both emitters and you are done. That's how you can create a disintegration effect using Particle FX in Blender, both for static and animated meshes. But remember, Particle FX can do so much more. Don't forget to check it out along with my other procedural effects generators. Also, check out Fox Renderfarm to get your $30 render coupon and start rendering your next project today. Links in the description. Thanks for watching and until next time, see you later.